Beyond the last ember of our sun's light, there are oceans that have never felt a human wind. There are skies where rain may fall under alien constellations. Somewhere in that darkness, warmth and water may be whispering the same ancient promise they once whispered to Earth. We leave our world behind not with rockets, but with imagination, gliding outward through a cathedral of stars. The Milky Way unfurls like a frozen river of fire, and within it drift countless planets, most of them silent, frozen, or scorched. Yet among this cosmic multitude, astronomers have begun to notice a rare and tantalizing category of worlds. Planets that do not burn like furnaces, and do not sleep like ice tombs. Worlds that orbit their stars at just the right distance, where light does not kill, and cold does not conquer. These are the temperate exoplanets, and among them may exist something even more specific and more seductive, the tropics of alien worlds. On Earth, the tropics are where life explodes into excess. Rainforests breathe out oxygen like living lungs. Coral reefs glow with colors that look like dreams painted in water. Warmth, light, and liquid water join in a delicate dance, and biology responds with endless invention. When scientists search for life beyond Earth, they search for this same choreography written on distant planets. They look for the possibility of water remaining liquid, not locked in ice or boiled into vapor. They look for temperatures that allow chemistry to become storytelling, where atoms learn to organize themselves into cells. For decades, these ideas lived only in equations and hope. But now, telescopes do not merely see stars. They feel the shadows of planets crossing them. When a distant world passes in front of its sun, a fraction of light is filtered through its atmosphere, and that light carries secrets. It carries the fingerprints of gases, the breath of alien skies. With instruments floating above Earth's atmosphere, humanity has begun to read these faint signals as if they were messages from another shore. What would a tropical exoplanet look like? Imagine continents carved by endless rain, where rivers glow under alien moons. Imagine clouds not white but tinted by unfamiliar chemistry, drifting across skies that may be violet or copper. The gravity might be stronger, making trees squat and broad, or weaker, allowing forests to stretch toward the heavens like living towers. Oceans could be shallower and warmer, their surfaces steaming under constant starlight. In such seas, life might not crawl onto land, but rise into the air, drifting like translucent balloons, feeding on sunlight and minerals dissolved in mist. Yet beauty alone does not make life. Life needs stability. It needs time. A planet must avoid violent flares from its star that could strip away its atmosphere. It must hold onto its water, not losing it to space like a sigh in vacuum. It must spin in a way that does not freeze one side and burn the other beyond recognition. Many red dwarf stars, though long-lived, can be temperamental in their youth, throwing storms of radiation like cosmic tantrums. And still, models suggest that some planets can survive these trials, cloaked in thick atmospheres or protected by magnetic fields, waiting patiently for calmer eras. The search for these worlds is not a poetic hobby. It is a scientific campaign led by the National Aeronautics and Space Administration and its partners across the planet. Space observatories study thousands of stars, cataloging their planets like explorers mapping islands. New telescopes analyze starlight with the precision of jewelers examining diamonds. They look for water vapor, for carbon dioxide, for methane, for oxygen. These are not just gases. They are storytellers. On Earth, oxygen is written by forests and oceans of algae. Methane can be written by microbes. When such gases appear together in an atmosphere, they may signal imbalance, and imbalance is the signature of life. Imagine the moment when data arrives showing a distant planet with warm temperatures and signs of water clouds. Imagine scientists watching graphs and numbers, realizing they are seeing weather on a world dozens of light years away. Rain, perhaps, falling on continents no human will ever walk. This is not fantasy. It is inference. A detective story written in photons. As intrigue deepens, the scale of this quest becomes dizzying. Our galaxy alone holds hundreds of billions of stars. Even if a tiny fraction hosts temperate planets, the number of potential tropical worlds could be counted not in dozens, but in millions. Each one is a laboratory where nature might have repeated its greatest experiment. Each one is a question mark shaped like a sphere. But the climax of this story is not merely about finding a planet with water. It is about finding a planet with a story. A world whose atmosphere bears scars of metabolism. A world where chemistry has crossed the invisible border into biology. Such a discovery would not bring spaceships overnight. It would bring perspective. It would tell us that life is not a miracle reserved for one small blue dot, but a tendency of the universe itself, a habit of matter when given enough warmth and time. And so we continue our journey through starlight, peering into the tropical belts of alien worlds. We imagine jungles beneath crimson suns. We imagine storms that have raged for millions of years. We imagine the first microbial colonies forming in shallow seas, unaware they are being watched from across the abyss. The universe does not speak in words, but in spectra and shadows. And in those shadows, we may soon read the most profound sentence humanity has ever known, that we are not alone in learning how to live under a warm sky.